Hello everyone, welcome again to this new lesson. And as we continue to explore our elements of design, I am super excited today to introduce to you the principle of colors. So before we go further, I would like us to actually answer the question of what is color? What is the color? So we are trying to answer this question here and this episode, and in the next episode we are going to explore more properties of the colors. But so far, let's try to understand what colors are. What is actually a color? Colors, to me, when it comes to our design, are the main ingredients. They are the ones that make up the final touches, the final beauty of design. It doesn't matter the color you use. Even if you stick to the black and white pattern, it still gives you the beauty once there is color. Colors can change your mood, like we said it earlier on in how design impacts our lives. Colors can change your mood and you can make you feel comfortable, happy, hungry or angry, excited, or any other forms of moods. The power of colors on us are inestimable, and that is why it is important that we dedicate some time to learn colors. Most people, most designs you see are more attractive, especially when the colors harmonies are successful. When the designer succeeds to harmonize the colors in the design. And that is why it is crucial that we take our time to learn about colors. When you understand the colors very well, there is a high probability that your work might be very wonderful. So in front of me here, I have an illustration in order to answer the question, what is a color? What is a color? Why is it that we see colors? So to answer that, we have to go back to the principle of light. We see light everywhere. The light from the sun, the light from the light bulbs, and those lights shine to our eyes in various colors. So you have the sunlight, sometimes shows red, sometimes shows white. Sometimes you have the light bulbs blue, green, orange, and so on and so forth. So finally, how does that happen? Where do we get that from? So the color we know actually is light. As light, like the sunlight. So that's why I'm illustrating here the sun. But the light of the sun comes to us in a particular shape, in a particular form. Then our brain takes care of it by interpreting these shapes and then giving us the feeling of perceiving a color. So it is actually a deceit of our brain to tell us that this and that, so and such, are these colors. So it is just our brain interpreting the light. And how does that happen? If we are perceiving light as just white light coming from the sun or from a light bulb, how does it happen that we see it in colors? So first of all, you need to look at how the light comes to us. It comes to us in what we call in a wave form. So light comes in wave form. So that's why I'm showing the light rays in a form of waves. So it waves. So the light reaches to us from the sun by following this pattern of waveforms. But all the rays are not having the same length, what we call the wavelength. What it means is, if we take, for example, let me take this brush and give it a different color of this so that I can see the difference. So when you take the difference between this area here to this area, you see the timing it takes for this to happen. The timing takes for this to happen on this wave is not necessarily the same timing it takes from this one to this one. So actually, this oscillation of the light waves are not following the same frequency, right? So how the pulsate over time is not the same from one wave to another wave. And for that purpose, human brain can only perceive a certain number of waves that respect a certain characteristics in terms of their pulse speed. So human being can only perceive with our eyes a certain wavelength So let's assume in our case we can only perceive these waves, the small ones over there with the smaller wavelengths. We cannot see them, so only human being can see these ones. So human being perceives somewhere in between 400 nanometers to 700 nanometers of wavelength. So waves of between 400 nanometers to 700 nanometers. These nanometers, it is very important that you understand it's so small, nanometers. So you can see this in terms of billions. So you divide 1 meter by 1 billion. That's when you get 400 meters. So you can imagine how short and small the wavelengths of the light are, and that is why it is impossible for our eyes to perceive that this pulsation of the light, this pulse of the light of coming to us in terms of waves, just like you see the waves of the sea. So how can we perceive the colors finally if it comes just in this, and if we can only see part of it? Why is it that we see the others? So what happens is this: when the wavelengths come through the atmosphere, through the air, and then through the dust or the water during the rain, the water actually reflects it. So let me increase my space so that I can get to explain that aspect. So once as the waves are coming to the light, so let me add one wave around here. So let's say we have a wave like this. So as waves arrive like this, the dust, the atmosphere, the air and water are somewhere here, and then the light wave goes through them. It goes through, they decompose it so into small components. So they divide it into small components. Actually, what makes up this light ray, what light wave? So it divides it into what we call a spectrum. A spectrum. So it divides it into a spectrum that we now perceive. So for example, in the spectrum of the white light that we see from the sun, we have the red, we have the orange, we have the yellow, so on and so forth until you have the violet here, and so many other colors here, and you have the violet. So in all, the white light from the sun has 7 more components. So in between here you will see the green. So let me add green. So I'll just write GR. You have blue, BL, indigo, then you have the violet. So when the light of the sun, the white light from the sun, crosses the atmosphere or water or the dust or something like that, or a crystal, so you could see that this plays a role of a crystal. Mostly we know it at school as a prism. This kind of crystals used to decompose light are called prism. So this plays the role of the prism. It will decompose the white light, and then we will perceive the smallest components of that light, and this whole set is called the spectrum of the light. So the white light spectrum is composed of these colors, and that's why we see it. And now you might ask yourself, so how come we see that some objects are looking green, some objects are looking blue, some objects are looking yellow, orange, and so on and so forth? So what happens if the spectrum comes in this composition of colors? How come we don't see objects just white? Because if all these light components are put together, if you make up these lights differently and you put them together, you end up with white light. So how come is it that they are coming as white light, and then once they reach the objects, a tree for example, so let's take a tree. So it reaches a tree, right? And then the tree is not looking white. How come? So the reason is this: objects especially natural objects, have something in them that is called a pigment. A pigment. The pigment is a chemical. So let me increase the space again. So the pigment is a chemical which absorbs the components of the light. So basically, the leaves of a tree absorbs all other colors except the green here. So green is 2A. So only that green that the pigment of the plant does not absorb. So like this. So it will absorb all others, and that particular pigment is called chlorophyll. We are not doing biology here. It's chlo. So chlorophyll. If I'm getting the name right, it's called chlorophyll. So the chlorophyll in the trees is called a pigment, and that pigment has the property of absorbing the red, orange, yellow, blue, indigo colors, violet colors, and then only leaving the green. Therefore, once it reaches the leaf, it will bounce back to the human eye that we are. So we only perceive that the plant has green color. And the same thing happens with all other objects, including ourselves as human beings, including our skin color. In human beings, we have a chemical, a component called the melanin. Depending on the type of the melanin, some of these lights will be absorbed, and then it will remain one color, and that is the color of your skin. So you being black is not actually you are black. It's actually what the eye manages to perceive in collaboration with your brain. That's what your brain manages to perceive. So you are not dark, you are not green, you are not yellow, you are not red, you are not white. You are just a perception. It is just a deceit from your eyes. Changing the color wouldn't matter much. So now that we know how the colors are perceived, how the colors actually exist, how they come to the existence, it is important that we further our study on it in our next episode. So I will add to this that not only natural pigment can be made, also man-made pigments. We have man-made pigments. So let me write it right. Man-made pigment. So man-made pigments are also used in order to generate different colors. So if we know the rule that we can just have a pigment, and the pigment will be in charge of either abstracting some parts of the light spectrum or adding parts of the light spectrum in order to give us the feeling of a color, then it becomes more interesting and more complex. And this is the science used in the paint industry. So in our next episode, we are going to explore the different properties of light or of colors. So how we can use them properly, how we can use them conveniently in our artwork. Now that we know the secret of light, now that we know that we can deceive, not as in a bad angle, but we can actually give people feelings, we can actually give people the idea of perception through colors, it is time we take it seriously. Thank you so much for watching this episode, and see you in the next video. Thank you.